These are your 5-1 and 5-2 notes on solving one-step inequalities. We kind of combine these because it's really a repeat of how to solve one-step equations, and it's just slightly different. So rather than spending a whole day solving using addition and subtraction, and then another day solving using multiplication and division, we'll do it all in one day. So an inequality is an open sentence that contains a less than sign, a greater than sign, a less than or equal to, or a greater than or equal to sign. No longer is it just an equation. So the difference is it will tell you not just one number, what it equals, but rather a range of numbers. So maybe in the first example there, that's the less than symbol. We read these things from left to right. So when I read the example, it says x is less than 3. You're describing x is representing every single value that's less than 3. So there's more than one number that is actually less than 3. So we graph them on the number line. When we make a number line, I don't need all the different numbers on there. I just need the number we're using. So when we talk about 3, 2 is less than 3, 1 is less than 3, 0 is less than 3, negative 100 is less than 3, negative a million, and so forever and ever and ever in this direction. And actually, I just gave you all the whole numbers, but we could talk about 2.5, 2.1, negative 2.5, all of these little tiny numbers in between. And so when I put every single number that's less than 3 on the number line, they get so close together that it becomes a continuous number, shade. It's shaded because those are all the decimals, fractions, rational, irrational numbers, positive and negatives that are less than 3. Now notice I didn't go right up to 3. I want to talk about that. 2.5 is less than 3, 2.9, 2.99, 2.9999999. And I could keep adding 9s forever and ever and ever. So we have to have a symbol that tells us that we are really close to 3, so close to 3, every decimal leading up to it, but not equal to 3. So how we do that is we put an open circle at 3, and that's our mathematical representation to say we're as really close to 3 as possible, but we're not including it. 2.99999999999. Okay? This lovely little symbol, the next symbol, is greater than, also more than. And so we read that from left to right. X represents all the values greater than 3. So when we draw a picture of those values, again, we put 3 on the number line. We're not going to include 3, so it's an open circle at 3. But now we're including all the numbers greater, like 4, 5, 6, 100, 1,000,000, 10 million. And right up to 3, but not including, so that open circle takes care of the 3.0000001. That's still greater than 3. A little bit, but it's still greater than 3. And so it's a continuous shaded region. I am drawing you a picture of all the numbers. I actually physically can't name all the solutions, so I provide you a picture and then you can see the solutions. If it's in the red shaded region, it's a solution. The next two symbols have this little line underneath it, and that little line is half of an equation. So it equals. So we're going to include the number now. So less than or equal to. The other thing that happens here with the less than or equal to, we sometimes say no more than. No more than means you can have less than that number, but you can have no more than 3 people in a group. Okay, well, you can have 3, but you can't have any more than that. So that would be 2. You could have 2, you could have 1. No more than 20 people in the room. You can have 20 in there, but you can't have 21, but you could have 19, up to that amount. Another way that they say that is at most. So these are the tricky ones. When they say that, it's hard to understand that that's less than or equal to. So again, when we graph this, we put the 3 on the number line. We have a closed circle now because we are going to include 3, and then we're going to include all those numbers less than it as well. So when you have the equal to, when you have this little line here, that means it's going to be closed. And then for this one, I don't know why this one's disappearing, but apparently I hit it. Oops. And so the last one, I can get rid of this box, is greater than or equal to, no less than, and also at least. At least. That box keeps getting in the way. You have to be at least 16 years old to drive. You can drive at 16, you can drive at 20, but 16 is the smallest number that you can be, so it's greater than or equal to that number. So we put the 3 on the number line, closed circle at 3, and everything to the right. So that shaded arrow is representing all the numbers that are greater than 3, and then we close the circle at 3 because we're including 3. Now these next couple slides are really boring, and I just want to use them for you to understand. We're going to summarize everything in here. I gave you everything, so you don't have to really write anything down. But what I wanted to show you, we did this with equality. We had properties of equality. And basically, these are the properties that allow us to use inverse operations to solve. And so what the addition and subtraction property says, if you have a quantity that's less than another quantity, so say 3 is less than 5. That's a true statement. If 3 is less than 5, and I decide to subtract 2 from both sides, so if I subtract 2 from both sides, the left side will still be less than the right side. So 3 take away 2 is 1. 5 take away 2 is 3. That's a subtraction property. Okay, 1 is less than 3. 3 was less than 5. The left side was less than the right side to begin with. And after I subtracted the same amount from both sides, it maintains that the left side is less than the right side. If I start with 3 less than 5 again, and this time I decide that I want to add 2 to both sides, the left side was less than the right. The left side now is 5. The right side is now 7. It's still less than the right. So the inequality is maintained. This is true for less than. So do you see how it was less than to begin with? If you add the same number, it'll still be less than. It's also true for greater than. If the left side is greater than the right, when you add a constant value to both sides, the left side will still be greater than the right. And the same thing holds true for subtraction. Less than is still less than, greater than is still greater than. It's a little bit different for multiplication and division. And so that's why I put them on a different screen. For the most part, it's the same. So in the green examples, it's the same. But when you multiply a number by a negative, it changes the value, the sign. If the number originally was positive and you multiply by a negative, it will now be negative. If it was negative to begin with and you multiply by a negative, it is now positive. So when you multiply or divide by a negative, it flips the inequality. So this is the part I wanted to show you. So do you see how it was less than here? The left side was less than the right side, and now it says greater than. The left side is greater than the right, and then it's less than. That only happens when it's a negative. If you look up above, these match. Less than, greater than, greater than. Because when you multiply by a positive, it's fine. So to give you an example of that, let's just use our 3 as 5. 3 is less than 5. If I multiply 3 by 2, and I multiply 5 by 2, 6 is less than 10. So it maintains the less than sign. Now let's use the same numbers and say 3 is less than 5. Now I'm going to multiply 3 by a negative 2. And when I multiply by negative 2, this side turns into negative 6. The right-hand side turns into negative 10. Negative 6 is actually greater than negative 10 because in the negative numbers, the bigger the number value, the smaller it actually is. So negative 10 is actually smaller than negative 6, and so I have to actually flip my inequality now. So we went from a less than symbol to a greater than symbol. Okay, for division, same thing. I'll just quickly show you. 3 is less than 5. So if I divide 3 by 5, and I divide 5 by 5, 3/5 is still less than 1 whole. Okay? But if I change that to be a negative 5, 3 less than 5. The left side is less than the right. And I divide by a negative 5. On the left-hand side, I'm getting a negative 3/5. On the right-hand side, I'm getting negative 1. Negative 1 is actually smaller than negative 3/5 because it's further towards the negatives. So as a summary, when solving using addition or subtraction, the inequality stays the same. If it was less than in the beginning, it's still pointing less than in the end. When using multiplication or division of a positive number, if you multiply both sides by a positive number, it also stays the same. But when you're solving using multiplication or division of a negative number, you have to flip the inequality. So that's really the only difference between solving equations and solving inequalities is this whole negative number thing for multiplication and division. So let's go ahead and try some. We're going to solve them. We're going to write our solutions in this thing called a set builder notation. Okay, we can't just say x equals something now, so we got to get a little fancy about it. And then we're going to draw a picture of our answers. So if you look at this first equation or inequality, sorry, not equation, we're going to add 12 because that's the inverse operation of subtract 12. What's happening to x? It's being subtracted from 12, so we need to add 12. X is less than 20. Okay, I kept my inequality the same direction because I was just adding. This whole set builder notation, are you ready? We're going to put a line out in front. We're going to put a variable out in front, and then we're going to put the set little brackets around it, or braces. When you read that, it reads, the answer is x when x is less than 20. And basically what it's saying is I can't give you one solution, so I'll describe it to you. So this is the fancy mathematical way to give answers when you have more than one answer. Well, the answer is x when x is less than 20. And then we draw a picture of it. So I want you to draw a number line. The only number I need to see on your number line is 20. I don't care where it's at. Okay, there's 20. It's going to be an open circle at 20 because it's less than 20, so we're not including 20. And then the numbers less than 20 are to the left of 20. They're before 20, like 19, 18, 17, 0. They're all to the left. So I want to draw you a picture. If I can find a number in that shaded region, it's a solution. I drew a picture of the solutions. Okay, number 2 here, we're adding 5 to m. So to undo that, we need to subtract 5 from both sides. M is greater than or equal to negative 12. Put your line out in front, put the variable out in front, and put it in set builder notation. M such that m is greater than or equal to negative 12. It's not a big deal. It's just an extra little step. But I want you to be able to recognize that. If you ever see that on like the SAT or the PSAT, I don't want you to be freaked out by it. So just exposing you to that form of writing your answers helps you later on so you're not afraid of it. We're going to put negative 12 on the number line. That little line underneath our greater than sign means greater than or equal to. So this time we're going to include negative 12 in our solutions. And then greater than negative 12 are the numbers to the right. The way the number line works, right is bigger, left is smaller. So just make sure I can see your shading. You can even get a little fancy or use a highlighter, colored pen, whatever you want to do. All right, let's try a couple more. 5x is less than or equal to negative 20. So I'm multiplying here. So I'm going to divide by 5. Divide by 5. I'm dividing by a positive 5. So I don't have to flip the inequality. X is less than or equal to negative 4. I don't care about the negative 20. It's what did you divide by? Is that positive or negative? Throw your X out in front in your line. Put it in set builder notation. Graph your line or your solution on number line. Negative 4. Since it's equal to, I'm going to put a closed circle at negative 4. And then the values less than that are to the left. There you have it. Number 4 is x is being divided by 3. So if I times x by 3, 3 divided by 3 cancels. Whatever I do to one side, I have to do to the other. I'm multiplying by a positive 3, so it does not change my inequality. So x is greater than 12. Put it in set builder notation, graph it on the number line. So we have 12 on our number line. We are not including 12, so it's an open circle at 12, and then shaded to the right because it's greater than. Couple more. Now I've got some negatives. I wanted to show you a couple of examples with negatives. So I'm going to divide by -2. I'm dividing by a negative, so when I simplify this, n is no longer going to be greater than or equal to 36. It's going to be less than or equal to 36. And 36 divided by -2 is -18. Put it in set builder. Put it on the number line. And it's going to be a closed circle at -18 because of that little line. That means equals. And n is less than or equal to -18. That means it's all the values to the left. I'm describing the n values. These are all the numbers less than -18. For number 6, I'm going to multiply both sides by -4. When you multiply by -4 and divide by -4, you're just left with a t. Since I multiply by a negative, I got to flip my inequality from greater than to less than. And the -6 and the -4 makes positive 24. Put it in set builder notation, and then put it on the number line. So my solution is going to be open circle because we are not including 24 and everything to the left. These are all the values. Include the arrow in your drawing, less than 24. Couple word problems. So we need to write the inequality, solve, and do everything we did before. A number, n, increased by 4 is greater than 9. There's my inequality. So I just changed the words into variables and symbols. Subtract 4 from both sides. N is greater than 5. Set builder notation. The more you do it, the more comfortable you are with it. And the number line. Draw a picture of it. It's going to be an open circle at 5 and everything to the right. Number 8. 3 times a number, so that would be 3n, is no more than. Is no more than means less than or equal to 21. No more than means it can be 21. 20 is no more than 21. 19, so those are all less than. Divide by 3. N is less than or equal to 7. Put it in set builder. I didn't have to flip the inequality because I divided by a positive 3. 7 goes on my number line. Since it's equal to, we're going to close the circle. It's going to be a closed circle at 7, and all the values less than are to the left. And here's your lesson summary and practice problem. Good luck.